There are two kinds of skeptics. One rejects anything that challenges the current paradigm, regardless of evidence, and the other is willing to ask uncomfortable questions and follow the data wherever it leads. I've always been the second type. My work in reversing aging didn't start with supplements, protocols, or clinics. It started with regulatory peptides. I was studying molecules produced in nature that were designed to restore access to gene expression programs that decline with age and disease. At face value, that idea sounds implausible to a lot of people. And for a long time, I assumed it couldn't be true. But when I stepped outside conventional Western frameworks and focused on the biology itself, specifically on why systems lose the ability to regulate and repair, it became clear that these molecules did work. In some cases, they worked remarkably well. And that's where the real problem emerged. Across different compounds, different mechanisms, and different people, the same thing kept happening. The interventions would work, sometimes dramatically, but only under certain conditions. Even at identical doses, outcomes varied, and when they did work, the effects often didn't hold. That pattern led to a conclusion that signaling molecules are only as effective as the biological system prepared to receive them. Most people who get serious about longevity eventually run into the same problem. An intervention works at first, a positive effect is noticed, sometimes even dramatically, and then it doesn't last. The improvement plateaus, fades, or reverses, even though the intervention itself hasn't changed. This happens with supplements, peptides, pharmaceuticals, and even stem cell therapies. The consistency of that pattern matters because it tells us that the failure is not intervention specific. When fundamentally different tools break in the same way, the problem is almost never the tool. It's the system receiving it. That constraint is not mysterious, but it is rarely discussed. For any biological intervention to produce a durable effect, the system has to meet three conditions simultaneously. It must have enough usable energy to respond without borrowing from the future. It must be able to interpret the signal clearly without distortion or conflict, and it must be able to stabilize the resulting change so that it becomes a new baseline rather than a temporary deviation. If any of those conditions fails, then your improvement is transient by definition. And this isn't just a theory being put out there, it's logic that is grounded in biology. Energy is not just calories or ATP generated, it's mitochondrial efficiency, redox balance, immune cost, and metabolic reserve. When you have energy that is marginal, the organism prioritizes survival and suppresses any attempts at adaptation in the way you may hope with interventions. The signal clarity depends on having intact receptors, accessible DNA, feedback loops, and cross-system coordination between the immune, endocrine, neural, and metabolic networks. When signaling is noisy, increasing the dose or layering additional interventions that aren't thought out carefully doesn't fix interpretation. It just amplifies the distortion of the signal. Stability is governed by homeostatic set points, including immune memory, tissue remodeling, and structural reserve capacity. Without that stability, the body doesn't lock the improvements in. It props it up temporarily, which feels like success to some people, until the intervention is reduced or removed. Then it all comes down. This explains why escalation often feels necessary, and why it also so often backfires. Escalation temporarily overcomes one constraint, but it can worsen the others. Higher doses amplify the signal, but accelerate counter-regulation. So you get stronger interventions that mobilize energy, but they may deplete reserve. Regenerative inputs demand stability that isn't present, and the initial response is real. Biology complies, but it does so by compensating, not by reorganizing and locking in the improvements. Compensation looks like progress until it collapses. This is why the same intervention can feel powerful and then disappear. It's because your biology is responding, but it's not reorganizing and consolidating those gains. Signals are being emitted, but the machinery required to interpret, amplify, and stabilize them is degraded. And without that machinery functioning properly, even correct inputs produce only transient effects. It's easy to assume that the intervention itself will fix the machinery, but in practice, that's rarely what happens. Stem cell therapies make this especially clear. They're often treated as fundamentally different, as if living cells bypass the systemic limits of the organism receiving them, but they don't. Stem cells require functional circulation, immune signaling, metabolic energy, controlled inflammation, and a viable niche to integrate and persist. Without that, all you get is a transient burst of signaling that the body can't meaningfully use. When those conditions aren't met, the cells do not persist for long. Think of it like planting expensive seeds into toxic soil. Any benefit that follows is typically due to short-lived signaling, anti-inflammatory or trophic effects, and not structural regeneration. And that distinction matters because signaling without integration cannot produce durable change. This outcome is not surprising in the least, and it's not a problem with the stem cells itself, but with the biology receiving the intervention without preparation. Autologous stem cells, those are ones from your own body, fail for the same reason. They're introduced into the same hostile environment that caused the endogenous regeneration to decline and collapse in the first place. Nothing upstream changes. What all of this points to is a missing variable that almost no one evaluates before intervening: biological readiness. Readiness determines whether a system can receive a signal, interpret it correctly, and hold the resulting change without destabilizing itself. When readiness is low, the pattern is always the same. Interventions do something, but they don't settle. Gains require constant reinforcement, and the system becomes dependent on timing, dosing, and escalation just to maintain baseline function. If you miss a step, the effects disappear. And this isn't what I consider to be optimization. It's really just fragility. And when readiness is restored, the behavior of the system changes. Interventions no longer need to overpower the resistance. Smaller inputs can produce clearer effects, and improvements persist even when the intervention is reduced or removed. This is because the system starts to cooperate instead of push back. And this is where most modern longevity efforts go wrong. They focused almost entirely on optimization and improving markers, activating pathways, increasing output, but without asking whether the system can actually support those changes long term. The result is improvement that only holds as long as the intervention is constantly applied. And optimization increases demand on the system. Readiness determines whether that demand can be met. And this is not an argument against optimization. Optimization is necessary, but it's also downstream. When governance comes first and readiness is restored, optimization stops being fragile. Markers improve without constant escalation, and pathways respond without being forced. Output increases without depleting reserve. In a governed system, optimization finally behaves the way that science says it should. That's what governance actually means. It's the difference between managing interactions and simply adding force. Governance means sequencing pressure appropriately and protecting future capacity instead of consuming it all. Optimized systems require constant interventions just to hold gains, but governed systems don't. They stabilize improvements, tolerate variation, and stop treating every missed input as a crisis. So when biology is governed, responses become predictable. The improvements stabilize instead of oscillating, and escalation becomes unnecessary because the system is no longer resisting or counter-regulating the intervention itself. The widespread failure of longevity interventions isn't evidence that the science is fake or incomplete either. It's evidence that downstream tools are being applied to systems that no longer have the structural permission to change. And until those upstream constraints are addressed, your improvements cannot hold, no matter how advanced the intervention may appear. And that's why the biological Recode system, BRS, exists. It's designed to identify and restore biological readiness and to optimize biology at the systems level by governing how pathways are activated, how interventions are combined, and how pressure is applied over time. Because when biology is governed, optimization stops being so fragile. It becomes stable, compounding, and predictable. Markers improve without constant escalation. Pathways respond without being forced, and output increases without depleting reserve. That's the difference between people who are chasing effects and achieving real biological optimization. And after years of watching this exact pattern repeat, not only in myself early on, but my family, and across hundreds of clients, it became clear that adding more interventions wasn't the answer. The problem wasn't a lack of tools in most cases. It was the absence of governance. And that's why I built the biological Recode system, to govern biology, assure readiness, and deliver optimization at a level no standalone intervention can achieve. If you want to apply for access to the biological Recode system, there is a link in the description. You can check it out. This has been Brenden Henry, founder of the Peptide Science Institute, author of Peptide Salvation, and founder of Cutting Edge Longevity. Thank you for watching, and I hope you have a great day.